In next few videos, what I will be concentrating on are some specific derivatives, like the trigonometric functions. It's very important to know how to derive the derivative of it, okay? So when we are differentiating, say for example, sine x. So how do I differentiate sine x? My task is to find out f dash x, okay, of sine x. So f dash of actually sine x, okay. So that's our task. So again, what we will be doing is we will be using the first principles. So my first job is to find out the ratio del f upon del x, okay. So change in f upon change in x, that's the first and foremost. Now change in f consists of two expressions, x plus delta x minus sine x, right? Now what is sine x plus delta x? What can help me find it out is essentially the property of trigonometry, the sine property, sine a plus b. Now sine a plus b, what is sine a plus b? Sine a plus b essentially is sine a cos b plus cos a sine b. Sine a plus b is sine a cos b cos a sine b. Just make a note of it. It's a very important property in trigonometry and maths otherwise. So just substituting in place of sine x plus delta x, what would it be? It will be sine x cos delta x cos x sine delta x. So this is my a, this is my b. You understand? X is my a, delta x is my b, change in x. So sine x cos change in x, cos x sine change in x minus sine x upon delta x. So now what do I see here in the numerator? In the numerator I see something peculiar, which is that sine x comes here as well as here. So let me just take it out. Let me just take it out as common. So I can take out sine x common. What will be remaining with me is cos delta x minus 1. If I open this bracket, I get sine x cos delta x minus sine x. So that's what it is. And the remaining thing that is with us is cos x sine delta x whole upon delta x. So just separating these two parts, okay. I want to connect delta x out here in the denominator with cos delta x minus 1 in the numerator, and delta x in this term with sine delta x here. And next attempt has to be to look at the limit as delta x tends to 0. So delta x tends to 0, what will this be? When delta x tends to 0, cos delta x minus 1 upon delta x essentially is 0. This is again a very crucial property of trigonometry using limits, which we will be solving. I will be telling you why exactly it is like this in detail in next few lectures. Currently you need to know that this is an extremely important property of cos and sine. Essentially sine x upon x as limit x tends to 0 equals to 1, and limit x tends to 0 cos x minus 1 upon x equals to 0, okay. Very crucial. Okay, in any case, so the moment I apply it, what do I get? The moment I apply it, I get that this part is 0 and this part is 1. So this whole thing becomes 0 and this becomes cos x. So the derivative of sin x is nothing else but cos x. So f dash x f dash x is cos x.